So motor manufacturers are certainly keen to increase the overall lifetime of their motors, but also reduce the total cost of ownership. So by that we mean the overall cost from the energy consumption and the cost of replacing and repairing as well. Certainly from the perspective of the overall lifetime, there are some significant issues around premature winding failure, for example, resulting in downtime, but also bearing failure. When we talk about bearing failure, about half of all motor failures are a result of bearing failures, whether that's issues around lubrication, overheating of the bearings, and misalignment of the bearings as well. Downtime is a significant issue for manufacturing professionals. It's estimated in the automotive industry that each minute of downtime equates to approximately $20,000 to $30,000 on each production line. So certainly an area where companies are looking to reduce, and obviously end customers of motors. But also there's the issue of energy efficiency. It's estimated that 70% of all electricity in industry is consumed by electric motors. And so certainly improving efficiencies in these motors will result in significant energy savings. Now certainly governments are keen to do this, and there are legislations promoting more efficient motors and the use of motor drives to improve these levels of efficiency. But certainly with these legislations there are loopholes and questions around how enforceable they are. Now we do however see that end users, they see increasingly the benefits of reducing these energy costs. They are looking at more efficient motors, and we're seeing a strong move to higher efficiency motors such as the IE4 super premium efficiency motors, which are growing at a double-digit rate, albeit from a relatively small base. So certainly we see new solutions and technologies around Industry 4.0 and IoT bring significant benefits to the end users certainly, but also to manufacturers. Motor manufacturers are looking at a market where capital expenditure is limited at the moment. We estimate the market from 2015 to 2020 is actually is going to be flat. And so companies are looking at different ways that they can continue to grow. And some of these IoT and Industry 4.0 solutions will allow them to address new business models and revenue streams. So there's a range of applications where this IoT or Industry 4.0 is really expected to make a difference in manufacturing in the future. And really the applications are very broad across the entire product lifecycle of a product that's being manufactured. That's everything from the design of the product initially through operation, the maintenance of the facility, and even the supply chain at the end. A few examples that we find particularly interesting. One is around the design of a product, but this can also be applied to the design of a motor, where software solutions are used to create a digital twin of a physical system. And here you can simulate the thermal flow or the current flow through a motor to help optimize the design and customize design for specific requirements digitally without having ever to create a physical solution. Another example is that of predictive maintenance. What predictive maintenance enables you to do is really just forecast when is my asset going to fail. So in terms of how that differs from traditional solutions where you may have reactive maintenance or preventative maintenance, where your maintenance is essentially done. It's reacting to problems or very inefficient in sending maintenance staff to check on assets that may be operating very well and have no degradation. Predictive maintenance allows you to understand and forecast when an asset might fail, so reducing downtime, and allocating work orders for your maintenance staff accordingly so that they are being utilised most effectively. Finally, there's also energy efficiency. So being able to understand from a motor perspective when a motor's performance is starting to degrade will allow you to repair it earlier on. This will help reduce energy consumption. So for example, if there is drag from degrading bearings, this is going to create heat and waste energy. Predictive maintenance solutions and energy management solutions will allow you then to monitor this, repair it early on, and it's estimated this can save as much as up to 30% of the energy costs over the lifetime of the motor. So really the difference between, if you like, Industry 4.0 and Industry 3.0, it is not so much about technology, or certainly that has a place, it's really about the outcomes. When we think of technologies, really the foundational blocks for Industry 4.0 or IoT is sensing and connectivity. Now, we've had these technologies for decades now, but really we're talking about a broader set of sensors collecting more information on a wider range of parameters and having this data collected from the sensors that are connected to allow for improved analytics of the data. So again, this is not necessarily a revolution, but more an evolution in the use of the technology. The real revolution is in terms of some of the outcomes where companies are able to improve the visibility across their entire factory floor and across multiple facilities. Companies are able to predict failures and downtime in advance, really reducing that. On the other side of the coin, the technologies really offer new opportunities for vendors as well. So giving them the ability to have a closer interaction with their customer base, for example, providing new digital services such as remote monitoring or remote servicing, but also allowing for closer interaction with customers through greater customization and tailoring of products to meet specific needs. And again, this is opening new revenue streams and new opportunities, which are especially important in a time when the market growth is a little bit more subdued.